Hi everybody, this is Katie Vandermeer and welcome to the last video I'm going to make on this chapter on file directory and permissions. There's a couple pages here because this is kind of a big topic, but if you've read the chapter already, it will help to understand what we're going to cover, and I'm going to try to go through it pretty quickly just to keep these videos short. So first of all, I'm back in my user1 home directory, and my current user is user1. So go ahead and super user or SU over to that person. And we have some files. Let me go to my home directory. And there we go. And we have some files, or we've kind of been working in the documents directory for this. And let's go into the CIS 132 directory. And since we are working in Chapter 4, let's go into the Chapter 4 directory. We've been working over in Chapter 1, doing different things. Okay, and here we have 3 files from earlier. Now, if you don't have those, that's okay. You can create them with touch. And you know, just they have nothing in them, I don't think. We can look. Yeah, they're all empty. So and then we just created them. So if you don't have these files in Chapter 4, just do touch file 1 space file 2 space file 3, and they're there. Okay, so what I did is I did a long listing. We have a shortcut, an alias set up called LL, or you could also do ls-l, same thing. I'm all for shortcuts, so LL it is. And here we can see the permissions and other information that's set on these files. So this first set that we see, these 9 characters, 9 spaces, not digits, 9 spaces, plus this 10th one, which is the very beginning one, so I guess the first one. These tell us whether we're looking at a file or a directory, and then also if also what permissions are set for that file or directory. So in Chapter 4, let's make a directory just so we can compare them. And we'll call it testdir, and then run LL again. So you can see what I was talking about. If it's a dash, that means it's a file. If it's a D, that means it's a directory. So we have files, and then we have a directory. Some of the commands we're going to look at in this section: change ownership, change group, and then change mod, which means change permissions for those files or directories. So to begin with, ownership. When you create a file, you're automatically the owner. So when I created these as user 1, I am that user. I'm the owner. If I was in this directory as root and I created a file there, then the owner would be root. So when you're going back and forth, since we are root, make sure you're careful where you're putting files. If you needed to change ownership, you could use the change ownership command, where you would do, let's say we would make the first, well, let's not use root, but let's say user 2, if there were a user 2, and then a command, the file. So here is change ownership, and then the first argument is who do you want to give permission to, or who do you want to make the new owner, and then the second argument is what file or directory do you want to give to make that person the owner of. So if there were a user 2 here, I would then take away my rights as user 1 to that file, and then they would now be the owner. So if you're working with a directory and you want to give that person permissions, you could do it that way. And if there were subdirectories and files and more subdirectories under that directory, you would do change ownership or chown and then a dash capital R for recursive, and then the user who is going to be the new owner and the name of the directory. So I don't have a user 2, so that wouldn't work. It would work if I typed in root, but one little thing you want to be careful about, unless you are root, if you give away your rights as a user, you can't take them back unless you're root. The only person who can do it is root. So if I'm user 1 right now. If I give away my rights, then I don't have them anymore, so I can't change anything. I'm not the owner of that. I would have no rights. That doesn't apply if you're root. Root can always change anything. So root's the top level admin, but users need to be careful when they're using the change ownership command. Another command that we could use is group, and this is to change the group that the file is, the group ownership that the file belongs in. So, or directory. So if I, when I create, let's see, when we're using LL, we have different things that we can read of this in this listing. These first 10 things are the permissions, and then here we looked at last video, these are symbolic links, and then the first name here is the owner, and then the next name is the group that the owner belongs to. So we don't have groups set up on our operating system other than a group called user 1. I'm a group of myself, so it doesn't really apply, but in a server environment, and you'll do this in your second class, we'll create groups, and then you can change or set permissions for just that whole group. So for example, if I had a group of students and I wanted to share a directory with all the students group, I would change the ownership. I would have you all as students in that student group, and then change the ownership on that directory or in that file to the students group. And then, so maybe it's a shared directory of some sort. Hold on. These are smashing my ears. Sorry, hopefully you can still hear me fine. So what this would do is change the ownership from whatever it was, like user 1 or the group that I belong to, which is the default, to students. And then anyone who is a member of that students group would have access to that shared directory. So we won't practice using that command, but it's part of the ownership commands that you learn about in this unit. It also takes 2 arguments. The first is the new group, and the second is the file or directory that you want to apply permissions to. Changing groups and owners can be done at the same time. So there's a couple examples in the book. Chown user 1 dot root file 1. What this means is it changes the owner of the file 1 to user 1, and also changes the group owner to root. So it's combining change ownership and change group by separating with a period. You can also do it with a colon. It gives you a couple examples in the chapter. And then recursively you could do with change ownership with a -r if you're working with a directory, and then the same syntax, user 1 dot root, and then if it were like your test directory, that's how you would change permissions and the owner to user 1, and then anyone who's a member of the root group or is root themselves would have permissions to that directory and all of the subdirectories below it. We'll do a couple things with change ownership, but for the most part, we're not going to change a lot of things there. Okay, let's get into looking at our permissions. So I'm going to clear my screen just to go back to my LL. First of all, when we're looking at permissions, you got to separate it in 3 different ways. We have permissions that we can apply to 3 groups: the user, also called the owner, but it's represented by an abbreviation of U. And then we have permissions that we can add to the group that the file or directory belongs to, and then permissions for other people in the system. So those would be others that aren't in the group that owns the file. So the users, the group, or others are permissions that you apply to somebody. And when we're looking, or to some file or directory. So when we're looking at this file 1, you'll see first that first dash means it's a file. If it's a D, it means it's a directory. And then the first 3 things, right here it says RW dash. The dash means there's no permission set. But the first 3 permissions there are permissions for the user, the owner of that file. So in this case, it's user 1. So what that means is user 1 on file 1 has the read and the write permission. The last permission is an X, and that means execute. So second one, the second set of 3, RW dash, again here, these are permissions that you apply to the group, which is designated with a G. And then everybody else, the others, is an O. That is this third group. So R dash dash, meaning they have they have the read permission, but not write or execute. So that's how you read permissions. The first thing is either for the most part, is either a file or directory, and then the next 3 are permissions that the owner has, and then the second set of 3 are permissions that the group has, and then the last set of 3 are permissions that other people on the system have. That's who you can assign rights to, permissions to. Now, what I had just mentioned too, you can assign them read, write, or execute. Here is this broken down to the user, which is a U, also sometimes called the owner, the group, which is a G, or the others, which is an O. If you're using all or referring to all of them, like UGO or UGO, you can also use an abbreviation A for all. And then the dash or the D is the directory or a file, and then X is the execute permission, and then W is the write, and R is the read permission. How do those get interpreted? Well, they mean something different on if it's a file or directory. So there's a table in your book. I know we're on the 4th edition, but it's the same table, table 4-4. And you want to be able to, you want to understand this. It's if you're talking about a file, read means you can open up and read the contents of a file. Write means you can open it, read it, and edit it, save it. And then execute means that you can execute it. So if it's a program, like a shell script that we write later in the semester, if it's a program that you write, you have to give it execute permissions. So read, write, execute, they're kind of self-explanatory on files. For directories, a read means you can list the contents of the directory if you've been giving, if you also have been given the execute. But read means if like the group and others have to this test directory, they have the read permission. Here they have read by the second set of R and this third set of R. So what they can do is they could navigate into this test directory and then do an ls and see every file name that's in there. So they can see all the files that are in a directory, which is why when we go to the root directory and do an ls, and if we looked at the permissions of these directories here, we all have, I'm root, or I'm an other in this case, but if you look at the permissions for others on these directories, we all have read and execute rights. So we can, anybody who is on the system can read the files that are in that directory. So I could go in the boot directory and list all the files there. I can't in lost and found because only root can do that. I don't have any permissions to lost and found. I don't have any permissions to the root directory. That's root's home directory, and I try to go in there and it won't allow me to. But if I went into the bin directory, I have read, I actually have write and execute, so I can do anything I want in there as user. That's not normal, but when we did our installation, we gave user 1 administrative rights, so that gave us those permissions. Write permissions on a directory means that we can add and delete files out of that directory. So we can add or remove files to and from a directory if we've been given executable, so they go along with that. Now notice I don't have write permissions as an other, or even people who are members of the root group, they don't have write permissions either. So we can't go into those directories, like the bin directory. I can't make a file here because I don't have the write permission. It's denied. The only place I can write files to is any place that I own or I have the write permission to. And then execute in a directory allows us to enter the directory and work with the directory contents. So they execute, it really means on a directory that you can search through it, but it also has to accompany read and write if you want to do things within that directory. The default permissions will cover, they're kind of loose as far as who can access what, so we can fix those later on. Okay, let's look at how we change permissions, and then let's go back to our home directory. So I'm going to go to my home directory where I actually have the ability to change and edit things. Notice it went from root to my home directory, and then again I want to go to that chapter 4 directory. So that was in my documents in CIS 132, and it was a directory called chapter 4. And there we go. We're back to where we were. Okay, changing permissions. This uses a command called chmod, C-H-M-O-D. My students in the past like to call it chmod, but it's not chmod. It's just funny to say that. It's chmod. And chmod is the command to change permissions. And this takes at least 2 criteria, like 2 arguments to use it. Changing permissions can be done. We're talking about changing these from whatever the defaults are to something more permissive or less permissive. So you can use symbolic notation or octal notation. Let's look at symbolic first. Both of these are explained in the book. Symbolic, I think, is more difficult personally because you have to usually know what's already there, what permissions are already set. And octal notation is short, sweet, and you just set the permissions. But you can do it however you want. Both ways accomplish the same thing as long as you do it properly and understand what you're doing. So unless an assignment or a certification question says something like, using symbolic notation, change the permissions on this directory or this file, then you can use whatever method you prefer. I would say that most people also agree and use the octal notation. It's just a little bit easier. You'll see here in a second. Okay, but we'll look at symbolic first. Symbolic's easy to understand, but it gets confusing when you want to change a lot of different permissions. So we have created files and directories. These are the default permissions because we didn't change anything. We have to consider these abbreviations in these operations, and then they're given these permissions. So we already looked at those. UGO, so we can assign rights to the user, the group, or the others. And then we can add using a plus. We can take away rights using the minus, or we can set rights using the equal sign. And then we use RWX for read, write, and execute. So looking at file 1, if I want to add the executable right for the owner of that file, the user of that file, I would do change mod. There's a couple of examples down here in these notes you can look at as well. But I would do change mod, and then I want to give the permissions to the user, so I would do u plus x space and then file 1. So what that means is take the execute a write and add it for the user or the owner of file 1. So now when I do LL, you'll see that that X shows up for the user group or the user person only, the owner only. Remember, the first 3 are the owner, so it changed from RW to RWX because I added that. Likewise, you could use change mod u minus x file 1, and it takes it away again. You can combine permissions and you can combine abbreviations. So you can do something like change mod, and then let's say we want to give the group and the owner executable rights. So you could do like UG plus X file 1 and UG meaning the user and the group plus executable, and you'll notice now we have 2 X permissions. So X permissions for the owner and X permissions for the group, or executable permissions. Taking them away using the minus. Now set is the equal sign, and you could do that as well. So you could say change mod u, like the let's say we want to give the owner all permissions, so we would say u, actually we could do u and g equal to, let's just give them right. We'll set it equal to, I'm sorry, read. So we'll say UG equals read in file 1. So what we did here is we didn't do anything with the O category, but we just set the permissions for the user in the group to read only. So R dash dash, because I took away my write and my execute, but because I didn't say UG equals RWX, I just said it equals R. So it doesn't matter what was there previously. It doesn't. It just sets it to whatever I tell it to do. If you want to set different types of permissions, you can use a comma to separate things. So you could do change mod, like let's give the user, the owner, let's give them all permissions. So I would say change mod u equals RWX, comma, and then group equals RW, and then, well, let's do GO equals RW, and then file 1. So I can, because these are different sets of permissions for different groups that I'm setting rights to, I can use a comma between those, and that will change those permissions. So now the user has all permissions, and then the group and the others have read and write permissions. So that's symbolic notation. There's a lot of examples in the book. A suggestion would be to use the set permission, the equal sign, because it doesn't matter what permissions they previously had, it just sets them to your new permissions. If it's a plus or a minus, it's not going to change any permission unless you specify it. So using the plus or the minus really means you have to know what permissions they already have. Otherwise, you're just going to add to the permissions they have or take away from what they have. Also, one other abbreviation you could do is A. So A would be all. So if you were doing something like change mod UGO minus X and then file 1, meaning you want to take away permissions for everyone, you could just as well do change mod A minus X file 1 and it would do the same thing. Take away execute permissions for everybody. All right, let's go on to octal notation. Now I know I'm going fast, but you have read the chapter, you're reading it, and you'll get some experience when you do your homework as well. Octal notation works on 3 numbers, read, write, and execute, and then all you have to remember is 4, 2, and 1. 4 is the read, 2 is the write permission, and 1 is the execute. And then all you have to know how to do is add those numbers together. So you need to know how to add. I think my glasses and my headset are irritating my ears. Hold on 1 second, please. Got some new glasses, so they're sitting kind of tight on my head. There we go. Feels a little bit better. My glasses are tipped down. Might look funny, but it feels better. Okay, so octal notation, you have to remember that 4 is for the read, 2 is for the write, and 1 is for the execute. And then the syntax for that is change mod. It uses the same thing. And then you give it 3 digits. The first digit is permission that you want to set for the user, the owner of the file. So if you give that a 7, then you're giving them 4 plus 2 is 6 plus 1 is 7. So you're giving them all of the permissions. If you put just a 4 in the first digit, that means they only have read. I keep saying that. If you do a 4, they only have the read permission. If you did a 6, they would only have the read and the write, but not execute. So there's only certain numbers. I mean, this can only add up to 4, 2, 1, 3, 7, 6, 5. I guess that's all the numbers it can add up to between 1 and 7. But, if you had a 5, if it was a 5, there's only one way you're going to come up with, if I can get that to come up, there's only one way you're going to add these 3 together to get 5, and that's by doing, 5 means you have the read and you have the execute. 3 means you have the write and the execute. By the way, you'll never see 3 because usually you don't want to write. You can't write if you don't have the read permission. It just doesn't make sense. But so you'll see common numbers like 644 is kind of a common one, or 700 is a common one. But all you need to do is add those up. So the first one is for the first digit is for the owner. So if I'm the owner and I want all permissions, I'm going to have a 7. Now, if you want to, the second digit are for the group. So if you want to give the group read and write permission, I'm going to go, 4 plus 2, so that's a 6. So they can have read and write. And then maybe people that are in the other category, I don't want them to have any permission, I would give them a 0. Or if I only wanted them to have read permission, I would give them a 4. And then say, let's work on file 2, for example. So here is what it was before. It was read, write, dash, read, write, dash, read, dash, dash. And what I want to, oh, that didn't change it at all. That won't change at all because, whoops, if I give them those permissions, oh yeah, it did give the execute to the owner, but now file 2, we are just setting permissions. So the owner now gets all of them. The group gets read and write, which is what they had before, and then everyone else has read, which is the 4. But if you did like 700 and then look at it, 700 is all permissions for the owner and then 0 permissions for the group and 0 permissions for everybody else. So they have nothing. See that? So that is octal notation. It's I think it's a lot easier because you're just setting them. You're setting the permissions that you want, and all you have to remember is 4, 2, and 1 and what it represents. Default permissions are also important. This is one of the most confusing parts of the chapter, so I'm going to try to briefly explain it. And file got mixed up. I'm trying to do it pretty quick too because I want to keep the video short. But I'm going to make a new file. I just typed the word file over there. I'm going to make a new file in chapter 4 directory called file 5. And then I'll do an LL. And so what we have here is file 5 and then a test directory that I just created too. I didn't do anything. I didn't change permissions on test directory. What you want to look at is the default permissions on a file and directory. And in all Linux systems, the default permissions here are our default permissions on this Fedora system after UMasks are set. So usually default permissions are pretty permissive, meaning they have more rights than they want than we want people to. So we set UMasks as system administrator. In this case, we set 002 as the UMask for our default permissions. That makes sense with what we see here. So new files are automatically given these permissions. For files, it's read, write, read, write, read, write for everybody. And then for directories, it's read, write, execute, read, write, execute, read, write, execute for everybody. So that's, you have a brand new file and directory that's created until UMasks are set. That is what all new files or directories will have. Because that's too permissive, we set a UMask. On Fedora, 002 is the UMask that was set. Only the last 3 digits when you type UMask, those are what you see. UMask can be changed. It's a system variable that can be changed by the system admin. I wonder if we can echo it. No. I guess I could try with a $sign. I don't know if it's no. I don't know if it's all capitals or if we can look at it. But anyway, UMasks are something that we can set, that it's a system variable that somebody can set on your operating system, and it can be changed. So the UMask that's set up by default on Fedora is 022, and what that means is that's the UMask number, and it's going to change the permissions from whatever the default permissions are. So on all systems, we're starting with read write dash read write dash read write dash for files, or read write execute all along the way for directories. one of the most common UMasks is 022, and there's a table in the book, and it explains what happens. Is you always start with the permissions, the default permissions. And with UMasks, what we're doing is taking away permissions and not assigning them. So if it's a 0, that means if the UMass number is a 0, that means it takes no permissions away. So what was an RW is still an RW because we didn't take anything away. And then the second set for the group, it was an RW dash, meaning they had read, write, no execute. But then we're taking away the 2 permission, which is write, correct? We're taking away that W. So now it becomes read dash dash. And then the third one is a 2 as well. So the default was RW dash, and now because we're taking away 2, which is the right, it just becomes R dash dash. And on a directory, if we do 022, we start again with what they have. And then what are our resulting permissions? Well, if we take away 0, the owner still has read, write, execute. And then they had read, write, and execute on a directory, but we're taking away 2, which is the right. So now it's now we are left with read and execute for the group and the others. On this Fedora system here, if we always start off with the same default, RW dash, RW dash, RW dash. Now the UMass set here is 002. So when I created my file 5, my resulting permissions, the 00 means I didn't take anything away. So I still have RW dash, RW dash. But I took away the write permission for the others, so that's where I'm left with the R dash dash. And if we use that same UMask with the test directory, we'll get the same results. Now, this I think is too permissive still. I personally wouldn't want members of my group to have write permissions on my directory. So that's where you would do something like 022 as a different UMask. So practicing a couple of those real quick. Let me just pull up a spreadsheet. It's just easier to look at with like a table. And let's just pull this up real quick. And let's say that we have a couple of examples. So remember, if we're working with a file, our default permissions are RW, if I can find the W, and then dash. RW dash R. Well, let's not use that. Let's just do a new document. It's a file. Get bigger so you can see it. So you'll be given questions that'll say, what are the resulting permissions if you assign the UMask of 017? So if the UMask is 017, what will the resulting permissions be? And what will they be on a file, and then what will it be on a directory? So on a file, we always start with the same. So the default is this, RW dash, RW dash, and I'm just putting spaces in there so it's easier to read. And what that number is basically the first 3 read and write, so that's really 6, 6, 6 because 4 plus 2 is 6, no execute. So if the UMask is set as 0, 1, 7, 1 and 7, that means that we are remember we're taking away. So for what this means is for the owner / user, we are taking away 0 permissions. So I know I spelled that horribly wrong. So if we started with the default of this here, what we're going to end up with if we take away 0 permissions is still an RW. And then let's go on to the next one, which is a 1. So the default is RW dash. So if we take away 1, 1 is execute, but they didn't have execute to begin with, so that's still RW dash. And then 7 means we take away from the others all permissions, so we are left with dash 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 for the last thing. So if 017 is a UMask, we always start with the default, then this is the resulting permissions that are on this file. RW dash, RW dash, dash dash dash. Do the same thing with a UMask of 272. Then for the owner user, we are taking 2, it shouldn't be, I shouldn't say 0 permissions. We are taking away the 2 permission. I guess is an easier way to write it. And the 2 permission is what? 4, 2, 1, so that's the right. So for the owner or the user, if we have 2 and we started off with the default of this, then we're left with R dash dash because we're just taking away the 2. 7, we already know that takes away all permissions. So 7 for the group, that would be left with 0 or dash dash dash. And then 2 would be taking away the right permission again. So for the others, it would be R dash dash. So if you had a UMask of 272 on a file, this would be the resulting permissions. And we'll say this is also known as 404, which isn't a common permission to set on a file. This is also known as read and write is 660. Directories are done differently because, well, it's done the same way, but the default on a directory is everything. So on a directory, the default we start with is RWX, RWX, RWX. So if we have a UMask of 0, 1, 7, and this is the default, the results would be we take away 0 permission, so we're still RWX. We take away 1, which is execute, so we have RW. And then we take away 7, which is all of them for the group. So that's the result if we were doing 017 as a UMask on a directory also known as 760. And then just lastly, the UMask of 272. What would that result be? If it was on a directory, we're starting with this. So take away 2. 2 is the right. So we're left with r-x for the owner. Take away 7 for the group. So we're left with dash, dash, dash. And then take away 2 for others. We're left with r-x, aka 505. Also not very common, but I hope you get it. Read the chapter. It will help you to understand it, and let me know if you have questions if you're one of my students. So thanks for watching. Bye.